Hi everyone, let's look at lesson 4. Lesson 4 is our first lesson involving data using two variables. What does that mean? Well, essentially it means that your variables are actually an ordered pair x and y. So if we just scroll back here, maybe to our list of data right here, temperature is considered a single variable because we've only listed a bunch of temperatures. So it doesn't associate with a second variable, like maybe, I don't know, this could have been associated with a day of the week or a year or something like this. Whereas, as you can see in lesson 6.4, we have two variables that can be associated as an ordered pair x, y. Now we talked previously in our previous unit about x being an independent variable and y being a dependent variable. Now we can kind of think about it this way as well in this unit, but sometimes the independent and dependent variables are more interchangeable. I will also point out that this data that we're seeing right here is discrete, meaning that these data points are individual points and you cannot use a line graph to join these points because they're separated, they're not continuous. So now that we've said that, let's have a look at scatter plots. I'm quite confident that you've seen a scatter plot before, but in this lesson we're going to look at some features of scatter plots, and we're also going to learn how to display them in a graph in Google Sheets. So the purpose of a scatter plot is really to establish a trend between our x and y values. That relationship would be called a correlation. So a correlation can be strong, it could be weak, or it could be positive or negative. So if we take a look at the 7 graphs to our right here, we can see that, first of all, a positive correlation, that has to do with sort of the slope. If you think of a line underlying this data, we could see that the slope of that line would be positive. So in other words, as variable A increases, variable B also increases. So you can think of that as a positive run and a positive rise. On the other hand, a negative correlation would be the opposite. As the variable increases, variable A increases, variable B decreases. We call that a negative correlation, and you can think of it as a negative slope. And then we can see that actually the trend is either like quite close to a line, which would be the top two charts, and we would consider that a strong correlation, or it could be like more loosely sort of in the trend of a line, which we would call moderate, or a weak positive or a weak negative correlation. You kind of just see a little bit of blank space in the corners here. Okay, but the data itself doesn't really follow the trend of a line. And then in the last case, there's no correlation at all. We would call this like pretty random. Okay, so here we have a fictional data set that includes an association, so an ordered pair between a reading score and a writing score. So each data point represents one person and their reading score and writing score on a fictional test. So if we plot this, we want to see if there is indeed a correlation. Does a low reading score associate to a low writing score? Does a low reading score associate to a high writing score? Is there no correlation at all? Let's find out. Okay, so the way we're going to do this is similar to yesterday's lesson. I'm going to pause the video here, or I'm going to ask your teacher to pause the video here, and I want you to click on this link and go through the motions of finding your own scatter plot. Okay, and then I want you to answer questions 1, 2, and 3, and then we can come back together on the video and we can answer these questions together. Okay, so get to it and I'll see you back here soon. All right, everyone. So if you have properly done the video, you should see a graph that looks something like this. And hopefully you've answered questions 1, 2, and 3. We will answer them together. So when I look at the correlation between a writing score and a reading score, I can see that the correlation, definitely is positive. And then I'm going to classify it as weak, moderate, or strong. And when I look at this, the way I judge that is by, this line that I've kind of, estimated. I'm going to look to see how far away the points are from that line. And when I do this, it's actually like, that's pretty close. Okay, so I would classify this as a strong positive correlation, meaning as your reading score increases, your writing score increases as well. Okay. Let's predict a student's writing score if their reading score is 70. So what that means is I want to kind of follow this line to see what the reading score or the writing score might be. So when I look at this, I think I'm going to estimate, maybe 73. Did I change anything on my graph to make the prediction? Well, no, I used this line though, so I did include a line. If I was still in my Google sheet, I might be able to manipulate this a little bit to see closer what my correlation might be. So for example, if I go back to my chart, I might be able to find some data points that have a reading score really close to 70. Okay, and then I can look at these two and say, well, yeah, I think those are the two closest ones. So although I'm making an estimate of 73, and I can see here that someone with the reading score of 72 actually has something lower than a 73, I'm still pretty happy with my estimate. And after all, it is an estimate. Okay, so let's predict what reading score would correlate or be attached to a writing score of 48. So I don't know, maybe here. So I'm going to say something like my estimate would be, that's 55, I'd say 52. Okay, let's look at another scatter plot. Natalie owns a coffee shop. As summer began, she kept track of the number of cups of coffee she sold each day and the maximum daily temperature. She's in the US, so it's degrees Fahrenheit. The data is shown on the graph. Okay, so let's describe the correlation between temperature and number of cups of coffee. Now remember, coffee is hot, so as the temperature increases, oftentimes people will choose a different drink instead of a cup of hot coffee. So if I were to describe the correlation between temperature and number of cups of coffee, maybe let's draw in a line, and I can see that definitely it's negative. And now I have to decide between weak, moderate, or strong. And if I, again, look at all the points around this, okay, I would think that's a strong negative correlation. It's pretty close to the equation of that line, whatever it would be. Let's predict how many cups of coffee she will sell when the temperature is 91. So if I continue my line along here, maybe let's do it this way. Okay, so I would say maybe 85. 85 cups. So can you think of any limitations this graphical model might have? Well, we just kind of saw it. So anytime I'm trying to predict how many cups of coffee, I'm looking at a graph and I'm trying to estimate the number of cups. So I think it would be a little bit better if we had an actual equation of a line that might be able to help us. So limitations are I am estimating by inspection, but wouldn't it be better if I had the equation of a line, this blue line, to be able to figure it out? It would be better to have the equation of a line, of the line, right? Y equals mx plus b. And then I could put in x as a temperature, and I could figure out what y is based on that. And then my answers would be more consistent. Okay, so we have just one more thing to cover in this lesson, and that's the issue of causality. So causality, the meaning of causality is that x directly causes an impact on y. So the independent variable directly causes a change in the dependent variable. So knowing whether or not something is causal can be used to make useful predictions. So for example, Toronto Hydro, which provides power to homes, would produce less power on a mild day because the correlation between electricity and weather, there is actually a high correlation between electricity demand and weather, because we will turn on our AC on very hot days or the heat on very cold days. So on mild days, when the heat is low or the AC is low, we actually use less power. And that's an example of a causal relationship, because the temperature directly causes a change in the demand for electricity. So this graph that we're about to look at is an example of somebody using two data pieces that actually are not causal to prove the point. So for example, pirates and global warming are used in this example as an effort to convince the Kansas Board of Education that correlation does not imply causation. So even though the x variable and the y variable are highly correlated, meaning when I look at this scatter plot, it looks very similar to a line, they don't actually mean that one, it doesn't actually mean that one causes the other. So we have to be really careful when we see that, you know, in fact, our scatter plot does follow the trend of a line. It doesn't mean that the number of pirates, as they decrease, and notice that this is a decreasing scale, that the world is getting hotter. We know the world is getting hotter for other reasons, okay? So what I'd like you to do now is make up your own non-causal relationship between two true things. So for example, we could think about something like, you know, I, Miss Fioroni, drink a lot of coffee. So we could make a claim that the more coffee I'm drinking causes me to get older. Okay, so we could put, you know, number of cups on the bottom and age as my dependent variable, and definitely this would go up because every day I drink coffee, so my number of cups of coffee will get higher and higher. However, we can see that that's not actually causing me to age, because if I stopped drinking coffee, I would still get older. But in fact, if I plotted the data, I would get a strong positive correlation. So I'm hoping you guys can make up one more example on your own, and then please, when you're done this, get on to the homework. You will be submitting it tomorrow, and as usual, please see us in Extra Help if you have any questions.